Hi everyone. So today my topic for this video is related to prerequisite of generative AI and prerequisite related to language or large language model. So if anyone want to start their career, anyone want to learn the generative AI from the basic point of view, and anyone want to go deep into the architect of language models or vision language model, large language model, so this video basically cover the prerequisite skills related to language model, like what are the common prerequisite skills required. So one of the important part, like core part behind the language models. So language model we know work very well on the on different tasks like the text generation, language translation on multiple tasks. But the core behind the language model is NLP, natural language processing. So NLP basically a field or a domain which focus only on the interaction between human language and computer. It basically include multiple algorithm, methods, techniques to understand, to analyze the human language so that we can use the data from the human language to to perform the different tasks such as the machine translation, sentiment analysis, speech recognition, chatbot, virtual assistant for multiple tasks. So these are the common applications of natural language processing, like the language translation. For example, if we have the problem to translate one language to another language, so we can use the NLP here. Smart assistant, document analysis, online search engine, predictive the text like the classification or some kind of prediction, automatic summarization, social media monitoring, chatbot, sentiment analysis, email filtering. So these are the few examples like where we use the NLP. So these are the basically common application on which we use the NLP. So let me show you one of the examples like this is the high level workflow. So this is the high level workflow of any NLP project, or you can say any uh, machine learning project as well. So but in NLP, one of the difference between machine learning, deep learning is like we have the data in textual format. One of the major difference between NLP and other project. So here basically first step would be the text data input or data collection, like collect the data from different sources. For example, if we scrap data from different website, so the step would be include the scraping if we have the data in JSON or other format, or if we load data from different data lakes. So that's the first step of any NLP project. Then we need to perform the data pre-processing. So here we have the textual data. So we pre-process the textual data as per the requirement, as per the application requirement. Then we need to perform the analysis, EDA, to find the best features, to see the feature representation. So here the step is the text representation. Then we have the feature selection, like in the EDA we find, okay, this feature is best and this text. And in case of text data, word we call the feature. So then we select the best feature, and then model selection and trainings, like we experiment with different models with different hyperparameter, then select the best model and then deploy those model on our instance or cloud instance in inference mode, and then evaluation and optimization as well, and then perform these all the step in iterations like the ML ops, or you can say the LLM ops. So this is the high level overview of one of the NLP project, like start from the data collection to data pre-processing, representation, feature selection, model selection, training, model deployment, evaluation, and iteration and improvement. So yeah, this is the workflow, like how we develop it and how we work in the NLP project. And here are the few common libraries of NLP. So one is NLTK. This is the most famous library. So NLTK basically we call the natural language toolkit. This is the one of the popular Python library for NLP tasks like the tokenization, streaming, lemmatization, part of speech tagging, and NER, basically name and entity recognition task. We can use this NLTK. And second one is the SpaCy. SpaCy also a very popular Python library for the NLP task, and it also used for the tokenization, NER, part of speech tagging, dependency parsing for variety of tasks. And TextBlob also, Gensim also, Scikit-Learn also, and Scikit-Learn. Mostly we use Scikit-Learn while we working on in any machine learning project, any machine learning pipeline. So generally we use this Scikit-Learn. And in NLTK and SpaCy, we have the choice. We can use one of them, or in some specific problem, we go with SpaCy. And Gensim basically we use for the word embeddings to create the word embeddings. So basically, to analyze the our textual data, context of our text data by using the word embeddings, and also for the topic modeling as well. So as shown in this diagram, there are the few library also, and in deep learning, generally we go with PyTorch. Once we work on the language model, then we use the PyTorch. And TensorFlow also we can use, but most of the time we use the PyTorch here. And so let me start with basic step. So in the NLP, the very basic step is to divide our text, basically to divide our text into the small piece of word, or we call those is the token. So first step in any NLP project is the tokenization. Tokenization basically is the process of breaking the text into the smaller piece. We call tokens, or we can call this the word. So for example, this is the sentence. So here basically we are using the NLTK, and from the NLTK tokenize, we import the word tokenize. So here we pass a sentence: the quick brown fox jump over the lazy dog, and then we perform the tokenization. So you can see here, this is the input text and this is the output. Now our word, these word basically we call the tokenize. This is the tokenize. Basically, we divide our sentence, whole sentence, into the different words. This is the input. This is the sentence, and these tokenize form is the basically after the tokenization process. We basically divide this whole sentence into the token format. So these are the token, like the quick brown folks. These are the token basically. So next step would be the streaming. Streaming basically a rule-based process to removing the suffix or prefix from a word to reduce those words to their root form. For example, running. If we have the running word, we can convert this word into the run form. And if we have the runner, we can convert this into the run format. So this way, basically, we perform the streaming. And it's basically a rule-based approach. And here also we are using the NLTK, and from the NLTK we are importing the quote streamer here. And then we have the tokenized data. So here we have the few words. Then we perform the streaming. So you can see here, these words basically convert into the root form. And we have the another mechanism also, another technique also to perform these, like the to convert word into their root form. So second option is the lemmatization. Lemmatization is the more you can say the more sophisticated process to reduce word into their base form or their root form. We call this form is a lemma. So and it basically consider the grammatical context while converting a word into the base form. So yeah, here basically we use the, again we are using, so here again we are using the NLTK, and we are downloading two corpus here, sorry, three corpus here. If we want to perform the lemmatization, so we need to import the lemmatizer here. So here wordnet lemmatizer we are importing here. And then before jumping to the lemmatizer, we need to perform the part of speech tagging as well. So I will cover this part of speech tagging later in next section. But to perform the lemmatization, first we need to perform the part of speech tagging. Part of speech tagging basically provide us the grammatical information, like okay, this word is noun, this is pronoun, this is verb. So basically we perform the part of speech tagging here and then perform the lemmatization. And after performing the lemmatization, you can see here these are the original sentence which we pass through this lemmatizer. This is the original sentence, and so this one is the original one, and this one is basically the lemmatized. So cat word basically convert into the cat's word convert into the cat, or you can see here better word basically convert into the good, and feeling is convert into the feel. So you can see here this way basically it considering, or it basically using the grammatical information also while performing the lemmatization, like by converting a word into the root form. So these are the basic NLP techniques, and we can say these are the prerequisite if we want to jump into the language model or generative AI. So next one is the part of speech tagging. Part of speech tagging is a process of labeling each word in the sentence as part of the speech. Like, okay, this word is noun as per the speech. This word is verb. This is the adjective. And here also we are using the NLTK. You can see here NLTK. First we are importing the tokenizer, then the part of speech tagging. So first we pass this particular text here, then perform the tokenization, then perform the part of speech tagging. So you can see here, now we have the grammatical structure, like part of speech tagging provide us the high level overview, like okay, this is the noun, this is the adjective, okay, this is the pronoun, or this is the verb. And now next I move to the text classification. So text classification is basically a category of supervised machine learning. So in supervised machine learning, we generally work on two kind of problem. One is classification, another one is regression. So if we have the problem like we need to predict a class, like yes or no. For example, if we have the problem, okay, we given data to our model and our model is predict yes or no. Then we call it a classification problem. And if our model predict continuous value like 1.0 or then 1.5 or then 2, then 3, 4, like the continuous value, then we call this is the regression problem. So further in the classification, if we have the textual data, if we have the textual data like the speech data or any string data or any document data, then we consider this is the text classification problem. So here are the common example of the text classification, like the spam filtering, sentiment analysis, topic modeling. These basically under the uh, text classification. And here we have the two way to perform the text classification. One is the rule based way. In the rule based way, basically we find the we classify our text based upon the specific keywords, like the fixed patterns, fixed rule. Okay, this keyword is found, okay, we can mark this as this text belong to this particular class, like by using the specific keyword, pattern, or regular expression. So second option here is the machine learning based classification. In the machine learning based classification, we basically trained our machine learning algorithm, machine learning model on the label textual data, and then our trained model basically perform the prediction, perform the classification on the unseen data. So those we call the machine learning based classification. So let me show you one of the example here. So here again, as I show you in the diagram in previous sections, like first step is the data collection, data pre-processing. So here basically we are loading our data. So here we are using the sklearn for the to split our data into the test and train format, and panda to load our data. So here basically we are loading our data. So here basically we are loading data from one of the Excel. This is the basically toy data set. So this is the toy data set. Like this data set has this particular text. You can see here, these are the text. And then we have the three classes here: positive, negative, and neutral. So you can see here, positive means if we compare this text like I love the quality of this product, highly recommended. So this is the positive review. Or second one, you can see here, if we compare this text with the review, second one, this service was terrible, I will not come back. So negative, and it's okay, but I expect more from it. So you can see here neutral. So you can see here we have the 15 data point, and it include positive, neutral, and negative, three type of data. So three basically in this text classification problem, we have the three classes: positive, negative, and neutral. And this is our textual data. So this basically our features, like this textual data contain our feature, and this is our predicted variable, output variable. So here our class is positive, negative, and neutral. This is our predictive class, and this is our feature, textual data. So but we know, like the machine learning or the computer understand the number only. So we need to convert these textual data into the number format before going to the machine learning. And in the next step, we basically dividing our data into the text and train format. So we are basically splitting our data, and we are basically providing 80% data into the testing training data set, and 20% into the testing data set. And now we need to convert these these textual data into the number format. So now we need to extract the feature from this textual data, and this is the textual data. First, we need to convert these textual data into the number format. So here basically we are going to convert these textual data into the vector format, so that our model can understand, because our machine learning model only understand the number. So here we are using the count vectorizer. Again, we are importing count vectorizer from the sklearn, feature extraction, text, and count vectorizer. So here basically we are converting our data, we transforming our data into the vector format. And now time to build our model. So here basically we are using the naive Bayes classifier from machine learning, and we are using the multinomial here, multinomial classifier. And if we now we train our you can see here, now we trained our model, and after the training we predict the accuracy. So now after the training we basically check the accuracy, we basically perform the evaluation here, and it is the 0.75. So here basically I explain you end-to-end flow of a NLP project with this toy data set. Obviously this is not the production level problem or production level code, but I will give you the like the rough idea, like how we work in the NLP, so that your base is clear related to the NLP part. So next problem in NLP, or next task in NLP, we work on the NER part. NER basically we call the name identity recognition. So this is the one of the very important task of the NLP domain, in which we basically extract, or we basically identify identities from the data. For example, the person name, or people name, organization name, location, date, or any numerical expression from the data. So basic work of NER is the to identify and extract these people's or organization location from the data. So here in this particular image, you can see here we basically identify or extract the NER from this text data. So Chinese as a nationality, and you can see here date, percentage, and so you can see here different data. Again, date, or Google, like the organization, IBM, Microsoft, these are the organization. And also few mistake here, you can see here AI is a person. So yeah, definitely there is the few mistake as well. But this way basically we extract, or we identify the identities, like the people name, organization name, location, date, numerical expression like percentage from the data. So let me show you in the code. So here again I'm using the NLTK. So this is the text, like the Steve Jobs was the CEO of Apple, and he was born on February 24, 1915 in San Francisco, California. So let me perform the tokenization first. So you can see here, this is the same code which we used previously for the tokenization. Then we need to perform the part of speech tagging. This is the also we cover this code in previous sections, part of speech tagging from NLTK. And now we need to find out, we need to extract the identities from data. So this is the basically tag tokens. After the part of speech tag, we pass this tag token into the our NER, and again we are using the NLTK and NE underscore chunk. This is basically the NLTK NER, and we are passing our data. It basically extract the identities, and you can see here this way it basically extract the identities if we perform the for loop on these all identities. So you can see here these are the actual value, like Steve is the actual value, and label which is marked by our NER is person, then Joke is person. So you can see here now San Francisco, California, all things are tagged as a geopolitical identity. So this way basically NER is work. And after the NER, let me again cover the classification with the help of one of the TextBlob library. And here basically in this particular case we are performing the sentiment analysis, and sentiment analysis basically provide us the information like how the customer sentiment related to our services, related to particular product topic, like the positive, negative or neutral, as I shown you in previous textual data as well. So here basically we are performing the sentiment analysis with the help of a pre-built sentiment analysis model from the TextBlob library. So here I'm importing the TextBlob, and this is the sentence I'm going to pass. And you can see here I'm passing this text data into the our TextBlob analyzer, and then I'm checking the sentiment polarity. So this is the polarity and this is the subjectivity. And if I basically print the polarity, so you can see here polarity is 0.661. So 0.662, sorry. So 0.6 means it the positive, like the sentiment of this text is positive, and subjectivity also high. So it basically give me the information like overall sentiment of this particular text is the positive. Yeah, and also if we read this sentence, I love this product, it works for me and is very easy to use. So overall this text is positive, like customer is love the product and it work great. So overall things is positive, that's why polarity is positive. Also subjectivity is high. And next example or next task in NLP is the topic modeling. Topic modeling basically a task to identify or to extract topic from a collection of text. Like we have the document, for example, we have the number of document and we don't have the time to read all the document. Then what we can do, we can perform the topic modeling and we can extract the topic from the our text data or our documents. And here we are using the LDL algorithm from Gensim or library. So first things we need to import Gensim and SpaCy here, and these are the document we are passing. So these document basically contain the textual data. Then we need to perform a few pre-processing like the tokenization, stop word removing, lemmatization, as we discussed in previous steps. So here basically we are performing the tokenization, and you can see here Here basically tokenization, then stop word is removing, and then performing the lemmatization, whole step in one go. And here are our pre-process data. And then we are creating the dictionary basically from our pre-processed text, and then we need to perform the topic modeling by our Gensim model, LDE model basically. So here basically we are defining our LDE model, and if we run this in for loop to see all the topics, so you can see here, this way it basically identify the topic. You can see here like topic 0, topic 1, and further we can dig down these things in detail also. But here in this video, our goal only give you the high level overview regarding the prerequisite of of language model, so that core concept regarding the NLP, like how we perform the topic modeling, how we extract the NER, how we perform the part of speech tagging. These things would be clear once you work on the language model. So primary goal for this particular course is generative AI and language model. So this particular video is all specifically related to the prerequisite step. And now I move to the one of the very important concept into the NLP is the word embedding. So word embedding basically a technique to convert our textual data into the vector format. In previous case, we use the count vectorizer like bag of word to convert our textual data into the vector format. But here we are using the machine learning model. Here like the AI model to convert our data from word to embedding format or vector format, and it basically capture the context information, like this word is mentioned in the sentence in which context as per the word in sentence or in paragraph. So it basically consider the word like the neighbor word of the sentence or of the document to find the context of the particular word. For example, you can see here, here we have the suppose word cat, kitty, dog, house, and these are the few words you can see here: gender, human, royalty, verb. So this way basically it basically generate the multiple dimension of vector of particular word, like the this for example, this is the seven dimension, this is the seven dimension, but in real time we have the 100 plus dimensions, or in large language we have the 1000 plus dimension model, and 1000 dimension of the embedding of models. But here for the learning purpose we use the seven dimension. You can see here 1, 2, 3, 4, 5, 6, and seven dimension of embedding. And this embedding basically the numerical representation with context information of this cat word, like this is the embedding of this particular cat word. Similarly, this is the embedding of this kitty word, this is the embedding of dog word, this is the embedding of house word. And if we convert these embedding from 7D to 2D by using the density reduction like the PCA, then it would be the hyperspace, like the high house word here, the distance between the house word and cat is high, and distance between the cat and kitten is low, distance between the dog and cat is low as compared to the house, and distance between house to dog is high as compared to cat. So this is the way like our data is converted into the embedding format by retaining the context information as well. Similarly, here are the man, woman, king, queen, these words. Here also we have the seven dimension. You can see here these are the seven dimension data embeddings, and if we see here, you can see like the man and woman. So the distance between the man or woman in vector data in this hyperspace, and also the distance between the queen and king word. So this way basically it capture the context information. Okay, cat word in what context, dog word in what context, man word in what context, king word in what context. So here basically we are use the AI algorithm or machine learning algorithm. So here we are going to use the Gensim library to perform the word embedding. And from the Gensim library, we are going to use the word to vec model. Again, we are using the textual data. This is the textual data. We need to perform some pre-processing similar to previous case. Here again, we are using the SpaCy to perform the stop word removal, tokenization, lemmatization, all the common steps. Then we are using the word to vec. You can see here we are using the word to vec, and with the help of this word to vec we are converting our data into the number format. This is the embedding. This embedding basically contain the context information, and here basically we are checking the embedding of one word folks. This is the embedding of the folks word, and it basically a vector representation of folks word with the context information, like folks word in this particular case, in which context basically we use the folks word. So it basically contain the context information, like in which context folks word is used or mentioned in this particular document. And if you want to find the similar word in the embedding, so here basically we have the method like from model word to vec most similar word related to dog. So it basically find the similar word from the embeddings information, like it use the embeddings to find the similar words related to the dog. So here red, jump, slow, these are the similar word as, as per the dog embedding. And you can see here are the similarity score is high as compared to jump, like the red similarity score is high as compared to the jump. Then then you can see here jump similarity score is high as compared to the slow, and again the similarity score is decreasing. And if we plot this information, like plot these embedding information into the 2D part, so here we are using the PCA to plot all the word here in hyperspace in 2D space. Basically this one is the 2D space. So these are the dog word. You can see here dog word, and the nearest word in the from the dog is the red, as we see in the similarity also, like the similarity between red and dog is high. So in 2D space also you can see like the dog and red, these the closest word, they are the similar word. Then after the dog, after the red, the distance between the jump and dog is less, and after the jump, distance between slow and dog is less. So you can see here, as per this information, we can plot this information also. So as per the embedding scores, we can plot these information in the 2D graph also. So this is the high level overview of word embedding. And if we perform same plotting with the help of another algorithm, TSNE, this is the another technique. So here also you can see this is the dog word, and this is the red word, the nearest word of the dog. Then this is the jump word. This is the slow word. So this is the another techniques. So that's all regarding the prerequisite part of a language model or generative AI. So in the prerequisite, we basically cover the basic idea of the NLP, like how we work into the NLP, like before the generative AI era or before the transformer era, how the things going into the NLP, how end-to-end project is going into the NLP, what are the common techniques like tokenization, lemmatization, streaming, part of speech tagging, NERs, embeddings, vectorization. So what are these common techniques, how we perform the sentiment, and these things basically we cover in this particular video. So this is the video related to the prerequisite of language model, and thank you for watching this.